Great. Well, thank you for the invitation to talk today. As I said, my name is Dylan Hodgkiss, and I'm an entomologist at ag-tech startup Olombria. And today I'm going to give you a brief introduction about the work we've been doing to quantify the benefits that hoverflies provide to soft fruit growers, both in terms of pollination, but also in terms of aphid pest control. So after a quick introduction, I'll go through a bit of background about the company, and I'll outline the aims, the way we are going to attempt to enhance pollination and pest control in soft fruit. I'll go over some research highlights from projects that we've done today before giving you an overview of the work that we did this past summer. And finally, I'll outline our future plans and the future studies we hope to conduct. So first, a bit about who I am and how my love affair with flies began. So I was originally interested in nature as a bird watcher, and it wasn't until I did a master's program looking at the invertebrates on green roofs that I switched my focus from birds to invertebrates. From doing pitfall traps on these green roofs, it became immediately clear just how diverse invertebrates are compared to birds, and how fascinating all the different life histories that can be found in the invertebrate world. So then moving on from that, I did a PhD looking at the benefits that hoverflies provide to strawberry growers in the UK. And through that, I did some cage trials looking at the pollination efficiency of surfing hoverflies, so that those with Ephidophagous larvae, because previous research had focused on Aristolans in strawberry. And through this cage trial, I was able to show that surfing hoverflies are also effective strawberry pollinators. They doubled proportions of marketable fruit compared to the insect-excluded controls. So that it shows that they have the potential of providing two ecosystem services with the same group of organisms, which is quite unusual. And then another thing that I found from the project was I put wildflowers within strawberry rows to see what effect that would have both on pollination and aphid control. So here I've got coriander growing in amongst strawberry row. And probably the most interesting finding from that work was that lacewings laid 3 times as many eggs on strawberry plants in the coriander plots compared to controls. So it seems like there might be some attraction for lacewings there. The number of pollinators were also increased in the plots with wildflowers, but unfortunately there wasn't any benefit in terms of fruit quality arising from that. And I think that might be because a lot of the pollinators were spending a lot of time on the wildflowers rather than on the strawberry flowers. So because strawberry is not particularly attractive compared to things like coriander. I think moving forward with that sort of work, I think the message is that choosing wildflower species that are in flower when the crop isn't in flower is probably the way forward, so that it provides pollinators with food source throughout the growing season, and also so that it doesn't compete with the crop and draw pollinators away from the crop. So anyway, in the course of studying hoverflies for my PhD, my interest then spilled over to a number of other fly families and groups as I was encountering them during my pollinator surveys. And now in my spare time, I go in my garden and try and find as many different insects as I can. And here are a few of the highlights from the last couple of years of some flies that I've found. But anyway, so moving on to Olombria and the work that we do. So our company is aiming to address the issue of the fact that we've got 75% of agricultural crop species relying on insect pollination, and yet the current options to growers in terms of managed pollinators don't seem to be sufficient. So part of the reason for that is that honeybees are struggling to keep up with the demand due to colony losses. But they're also facing additional pressures in terms of climate change, pesticide use, and there's a growing body of research that suggests that honeybees aren't necessarily the most effective pollinators for many crop species. And so, against the backdrop of increasing insect declines, all of this amounts to quite a big threat to food security. And so Olombria is aiming to address that using alternative pollinators. So just a bit more about honeybees. So one of the issues facing growers is that hive rental costs are growing significantly, and at the same time, the supply of available hives isn't meeting the demand. Currently, it's estimated that about 4 billion pounds per year are spent on pollination, but this figure is dwarfed in comparison to the benefit that we get from pollinators. In 2009, it was estimated that the global value of pollinators to our agriculture is around 150 billion pounds per year. And in the intervening decade, the number of pollinator-dependent crops that are grown has increased, so that number has undoubtedly increased since then. So what Olombria offers is a complete system where we set up data devices throughout the crop which monitor flower visitation rates. We then release lab-reared hoverflies, and then we have a system of lures that can be switched on or off to attract the pollinators throughout the whole crop, so that an even pollination service is delivered. And then built into the cameras, we also have an AI system that will identify the pollinators to functional groups. So whether it's a honeybee, bumblebee, hoverfly, or other family of fly. And then this information will all get fed to the growers so they can have a sort of real-time information about the pollination service in their crop. And this is really important because currently growers are very aware of their aphid problems because it's a very sort of visible issue, but with pollination deficits, they're not. It's not something that's so easy to see. And so we're hoping that through this service, we'll be able to highlight that and show how they can increase their yields through better pollination. So moving on to some of the research that we've conducted to date. So in 2019, we looked at the effects of our semi-chemical lures on the pollination service. So we set up a trial in a polytunnel where we had strawberry plants arranged at either end of the tunnel. At one end, we set up our lures, and the others were just the plants by themselves. And then when we released hoverflies in the middle of the tunnel and allowed them to go to whichever end they preferred, we found that the resulting fruit quality from the two groups of plants was quite different. So we had 18% heavier fruit on the end of the tunnel where the lures were set up compared to the controls. So that is quite a significant increase. Then moving on from that study, we then looked at the effects of introducing flies on pollination success. And so this time we were set up in a commercial raspberry field, and we had 10 tunnels and five different treatments. So we had 2 lures that we were testing out, both separately and in combination. And then we had flies released in 4 of the tunnels and then 1 control without, for the treatments, and no flies or lures in the control treatment. And from this study, again, we found a large increase in fruit quality in the compared to the controls. So the treatments with introduced flies had on average 50% heavier raspberries compared to the controls, which I think says 2 things about the situation. So one is that it seems that in the control tunnels with the wild pollinators that were there, as well as some honeybees, the pollination service that was being delivered was suboptimal. And when we introduced flies, that significantly increased the yields. So building on those 2 studies, this past summer we sort of combined the 2 and looked at the effects of flies and lures on pollination success. And this year, for the first time, we also looked at aphid control at the same time. So we had 5 farm sites spread out, 2 in the southeast and 3 in the West Midlands. And this time we had a larger number of treatments. So we set up with, this time we had treatments where just the lures were set up, other ones with lures and flies. We had a positive control with just the flies and no lures, and then a negative control with nothing in it. And so this is an example of one of the fields. The colored tunnels are the different treatments, and then the the icons there where we had lures, and then the yellow where we released the flies, just to give you an example of what that looked like. And so the surveys that we carried out to see what impacts these different treatments had were aphid and natural enemy surveys. So we looked at, of course, we looked at hoverfly larvae, but we also made a note of any mummified aphids, lacewing larvae, ladybird larvae, to see if any of these other predators were also impacted by the treatments. We, of course, looked at flower visitor surveys. And then lastly, we looked at fruit quality to see what the ultimate gain for the farmer would be at the end of the day. Unfortunately, we're still in the process of analyzing this data, so I don't have any results to share today. But we hope to have those ready in the next couple of months. So looking forward to the next growing seasons, one of the big things we want to look at next are glass houses, because this is something that's particularly well suited for hoverflies, we believe. Whereas commercial bumblebees or honeybees require that you bring in a whole hive, with hoverflies you can release as many or as few as necessary depending on the size of the container. Because obviously if you're working in a small growing container, you don't want a large hive of bumblebees in there. And another reason for that is that it presents a bit of a risk to the farm workers if you've got loads of bees flying around in a confined space, and hoverflies, of course, don't pose any threat to the farm workers. We're also looking at moving into new crops, so blackberry and blueberry are another two crops that we're looking at. And then finally, we want to look at cage trials to look at the benefits of pollination and aphid control, how they act together in concert, because studies in other crops have shown that rather than having a sort of additive benefit, pollination and aphid control can work synergistically to sort of produce a multiplicative benefit in yields. So we want to see if that's the case for hoverflies in strawberry as well. So yeah, that's about it. So thank you very much for your attention.
So, do we have any questions from the room? We do, right. I'll bring the microphone over.
Thanks for talking, it's really interesting. I believe with raspberries, if they self-fertilize, they produce inferior fruit. Yet if they fertilize from different plants, they actually produce much larger fruits. Does that, do you think, one of the underlying things that you're seeing is that by having more pollinators, you get pollination?
I think that's probably the case, and I think that's true of strawberry as well. In my PhD work, I found that the insect excluded fruit produced about 40 to 50% marketable fruit, whereas the insect pollinated treatment was over 90% marketable fruit. So there's a big benefit and a big cost when they choose to self-fertilize instead.
Thank you.
Presumably you're rearing the hoverflies.
That's
Is there
right, yeah.
a big cost?
Yeah, it is. I don't have any figures I can give you. I'm afraid I'm just on the science side of things, so I can't share any specifics about it. But yeah, and so we're looking at both Aphidophagous and aquatic species. So that there are sort of different processes obviously involved in rearing the two, and we've yet to sort of settle on what mix we're going to use going forward. But finances obviously factor into it as well.
Is there any specificity? Do they? I noticed that, like with blackfly or bees, seem to have a limited number of
Yeah, I mean, there are definitely specialist arborflies and generalist ones. So we're focusing on the generalist species. But yeah, I mean, there are things like the, Hyringia that specialize on the aphids in the galls of poplar leaves. And so, yeah, obviously that would be completely useless for a strawberry grower. But yeah. Yeah, so wild caught flies. No, I'm afraid until we have a product ready, we're not able to share that information, I'm afraid.
Sue Taylor is asking, where are the introduced flies coming from? Will there be impacts on wild populations? So yeah, you've answered part of that, haven't you?
Yeah, so it's only native.
Individuals
Yeah,
set up colonies.
That's right, yeah.
But impacts on wild populations. Am I right in saying most of your work so far has been in closed?
Yes, although we are working in polytunnels as well, so there is, it is conceivable that there could be some impacts on wild populations in those situations. But to be honest, these polytunnels are located in agricultural areas that are quite sort of species poor generally, in our experience. So I'm not sure how much of a impact it would have on the.
Flies that you're releasing are not tagged in any way.
No, that's right.
So you wouldn't be able to distinguish between.
That's right.
One of and one.
Yeah.
Okay, so interesting question too. Give you a full answer. Okay, Rob Walton, very interesting. How do you raise the hopperflies? Okay. Where do they overwinter? Are you also looking at pollination and pest control? Sorry, services outside of in a loop. Rob, if you're happy with the answers that we've given already, next question. Just put a thumbs up in them. Okay. Danny Kingsley. Okay, we're talking about the sound quality, right? Okay, Rob Walton is happy with the answer. Okay, so have you lost sound? Microphone's not on, so the lights on. Okay, I think, well, it's. I think we've finished the questions for Dylan anyway, so we should move on to the next presentation. So, yeah, thank you, Dylan.
Thank you.